All right, the simple machine for today is a wheel and axle. And in a lot of sources, what you will see, we're going to be talking about both wheel and axle and a pulley, and some books will classify those as two separate physical machine or two separate simple machines. Your book just classifies them as a wheel and axle and then subdivisions of that. So be aware that you may see this classified differently depending on where you're reading about it. So we're going to start with something that I forgot to tell you the last time about levers. And if you need a little mnemonic to help you remember which type of lever is which, you can use the phrase free 1, 2, 3. A first class lever will have the fulcrum in the middle. A second class lever will have the resistance in the middle, and a third class lever will have the effort in the middle. So if this free 1, 2, 3, there's just some free advice for you to help you keep track of which kind of lever is which. So because I had forgotten to mention that before, I wanted to make sure that I mentioned it now so that you can keep those different kinds of levers straight. So main topic for today, wheel and axle. Now a wheel and axle is something that the wheel and the axle have to be turning at the same time. If the wheel and the axle don't turn simultaneously, then you don't have a wheel and axle. Okay, so examples of a wheel and axle would be a doorknob, where you're going to turn the wheel and then the axle is on the inside to help you turn the latch for the door to get the door open. A screwdriver is actually a wheel and axle because you're turning the wheel part where the handle is fat and the axle part is down on the other end where it's much skinnier. So a screwdriver, if you have like an electric fan, that's going to be a wheel and axle where there you're turning the axle in order to make the fan go around. So in a wheel and axle, sometimes we turn the wheel and sometimes we turn the axle depending on what job we're trying to do with it. To calculate the mechanical advantage of a wheel and axle, all you have to do is take the radius of the wheel and divide it by the radius of the axle. Now, if you remember from your math classes, if you have a circle, the radius is the distance from the center to the outer edge, okay? So dividing the radius of the wheel by the radius of the axle will give you the mechanical advantage. Now, the interesting thing there is what the mechanical advantage will tell you depends on whether you're turning the wheel or whether you're turning the axle. So let's think about if I have a wheel that has a radius of 12 inches and I have an axle that has a radius of 1 inch. If I calculate the mechanical advantage of that wheel and axle system, the radius of the wheel is 12 inches, the radius of the axle is 1 inch, so the mechanical advantage is 12. Now, again, like I said, what this means depends on which part you're turning. Let's say that I'm talking about a doorknob where I'm actually turning the wheel portion of the wheel and axle. And so therefore, if you're not going to have a doorknob that's 12 inches big, but if you turn the wheel, you're going to multiply force. And so it's much easier to turn the wheel on the doorknob to get the door open because I don't want to turn that itty bitty piece in the middle to try to get the door open. That would be very difficult. So turning the wheel makes it much easier for me to multiply the force and get the door open. That's also why we use a screwdriver. Screws are really little, and if you try to turn those with your fingers, you normally can't get the screw in. But if you use a screwdriver and you use one with a pretty fat handle on it, then you turn the screwdriver and you can get the screw in much more easily. So here's a tip for you too. In fact, if you ever are trying to get a screw in and you're having trouble getting it into the wood, if you will change it out for a screwdriver that has a fatter handle on it, you'll probably have a much easier time getting your screw screwed in. Okay, so if I turn the wheel, I'm going to multiply force. If I turn the axle, I'm going to multiply distance as well as speed. And so if I think about an electric fan, the mechanism of an electric fan, you know the motor's kind of in the middle of the fan, and so the mechanism is turning the axle of the fan, but it's turning this great big huge fan around on the outside, And the faster it goes, the more air it produces and the cooler you feel. So here, I would be multiplying distance and speed by a factor of 12 if my axle is 1 inch and my the fan blades are 12 inches out. So the fan would multiply speed, whereas the doorknob is going to multiply force, because with the doorknob I'm turning the wheel, with the fan I'm turning the axle. Okay, so again, how you use that simple machine is going to tell you what that mechanical advantage actually means. Now, the other piece of section today is on pulleys. They mention gears. We're not going to go a lot into gears. Gears basically just are wheels and axles that have teeth that fit into each other. And if you wanted to calculate the mechanical advantage on that, you can do that by finding the ratio of the big gear to the little gear and counting the number of teeth and dividing that out, if that's something that you're interested in. Okay, we're going to concentrate quite a bit on pulleys. Pulleys are used quite extensively in some different types of machinery. If I have a really, really simple pulley, like I think I mentioned this in the first video, if you have like one of those old-fashioned wells and there's a pulley up at the top and the bucket goes down on one side and then you pull the rope on the other side to get the bucket full of water to come up. The whole purpose of this kind of pulley is simply to change the direction of your force, because it's much easier to pull down than it is to pull up. And so it will make your job easier here. So with this one, the mechanical advantage of this type of pulley is just 1. So I'm not multiplying force or distance. If this object that I'm trying to pull up weighs 1,000 newtons, then I'm going to have to apply 1,000 newtons of force for it to be able to lift this weight. So the amount of force in is going to be roughly equivalent to the amount of force out. There is going to be a small amount of friction between the rope and the pulley up here, but we're going to neglect that for purposes of this class. Now, the way you calculate mechanical advantage for other types of pulleys depends on whether the pulleys are fixed or whether the pulleys are movable. So my son really enjoys lifting weights and doing a lot of weight training. And so he has a weight machine down in our basement where it has a whole bunch of pulleys on it. And those pulleys are all fixed. They don't move. They're all attached to a piece of the machine, and this rope is all kind of threaded through them, and it's attached to a weight down here on the end. So if all of your pulleys are fixed, then you calculate the mechanical advantage of the pulley system by just counting the number of pulleys. So here, the mechanical advantage of this pulley system is 4, because I've got 4 pulleys in it. And so that's, here I will be able to put less force in and lift something that's 4 times as heavy as what the force looks like you would be able to lift otherwise. Okay, now we're not going to spend a whole lot of time again on fixed pulley systems. Your book tends to concentrate more on movable pulley systems, and these are the type of pulley systems that you're going to see in cranes, that you're going to see in a lot of the construction equipment that you may see. And so here with this particular case, this pulley is fixed because it's attached to something, but this pulley is not fixed. It's actually attached to the object that I'm going to be lifting up, or maybe there's a hook on this pulley down here. And so as I pull on this rope, this pulley is actually going to rise as I pull the rope through. Now, what you have to do is you have to count the number of ropes that are actually supporting the weight down here on the bottom. So here, this weight is being supported by both this rope and this rope, because this is the one I'm pulling on. Okay, so since there are 2 supporting ropes, the mechanical advantage of this pulley system is 2. So what that means is that if this is 1,000 newtons that I'm trying to raise up, I only have to put in 500 newtons of force, which is 1,000 divided by 2. But the trade-off, and remember, there's always a trade-off with machines. If you're going to be able to decrease the force, you're going to have to increase the distance. So I only have to put in 500 newtons of force in order to lift this, but I have to pull the rope 2 times as far, in order to be able to get this up. So in other words, if I want to lift this up a meter off the ground, I'm going to have to pull the rope 2 meters in order to get this to go up by 1 meter. Okay. This is called a block and tackle, and it has a whole number of pulleys in it. In fact, you can see 2 pulleys up here on the top and 2 pulleys down here on the bottom. So if I count again the number of supporting ropes, there's 1 here, there's 1 here, there's 1 here, and there's 1 here as far as the number of ropes that are actually supporting the weight of this object. I don't count this one because this is the one I'm pulling on. Okay, so here, since there are 4 ropes, the mechanical advantage of this pulley system, this block and tackle, is going to be 4 because of the number of supporting ropes. So what do you think? If this is 1,000 newtons, how much force am I going to have to pull on this with in order to lift this? Well, over here, I took the mechanical advantage and I divided, right? So if I take 1,000 and I divide it by 4, that means that I only have to pull with 250 newtons of force to lift this 1,000 Newton weight. Okay. However, I'm going to have to pull 4 times as far in order to get this lifted. So if I want to lift this up by 1 meter, I'm going to have to pull 4 meters of rope in order to get that to go up 1 meter. Okay. So you, again, today we'll be doing some problems where you're going to be calculating mechanical advantage of wheel and axle, telling what that mechanical advantage means, and figuring out the mechanical advantages for some pulley systems.